Howdy, and welcome to Broken Tool Garage. This video is going to be going over doing the port work on the cylinder head over here. I'm using the 318 head. It's like a 714 casting, which is a closed chambered, the later model closed chamber swirl port casting. So what I'm doing here is, if you have watched the Mission Impossible series from the Motortech group, I'm taking what the professionals there have done and trying to replicate Charlie's Quicky port. So you can see Charlie's Quicky port video in the card. It's also going to be down below. Thank you, Charlie, for helping me out on this. I've been emailing him back and forth, and he's been helping me with certain key areas on this and clarifications on some of the things. So again, I'm trying to replicate what the professionals have done, and I'm showing you what I'm doing. This is also, I have ported cylinder heads at the Enthusiast entry level many times, including this style head. What I'm doing with this is taking my skill level to the next level. And well, let's just get to it. Okay, here we are about to do the valve shrouding in here. I've marked those. I don't know how they're showing up on camera. Kind of see them in pencil. Like I painted it red and then I come in with pencil, so it just looks like a just not showing up as good as what I wanted it to. That's all that is. But anyways, what I did was, I'll show you what I did. This is what I did. I did the did. So I got my 1/4 inch little flow ball right here. What I did, I just lifted it up, you know, the same technique that's shown David Vizard shows, and you know, any of the porters are going to show you this if you're watching them, I'm sure. But got it up at about the 1/4 inch. Then I took and laid it right at this edge right there, and then kind of marked it all the way around, because that's what we're going to go to, is, you know, it has to kind of fit in that edge, and I just kind of walked it around roughly right there. Okay, let's look at why we are doing this. So it kind of showed you what I'm going to do, did it on both ones. Let's go into why you want to do this. Okay, we're going to do our side angle right here. See how that's lifting up? And we don't have any clearance from our wall, close wall right here, right? There's no airflow because it's right up against it. Now we're starting to see to where this is gapped open a little bit, where air can flow through here a little bit on this edge. All right, we're coming up on it. Okay, we now have clearance, just a little bit of clearance right there, right? See that? It's a little dark behind that valve, but we're just starting to get a little clearance in there. Let's see how much lift it took to get some clearance in there. Almost a 1/2 inch a lift before we even get any flow here. Let's look at it from the other side. All right, we're looking at it. See how that's just a wall right there? Wrong valve. I did this when I practiced this too. See how it's lifting and it's not past that wall, and we finally get past the wall, like way back, way up there, right? I mean, there's just no flow on that edge. And then we get the same thing around this area here. Now on this top side, let's look at it from this distance too. Right, see how that's just completely shrouded in. Up here it's not as bad if we look top down. We just need a little bit, because we're getting flow now. So basically right about there, we're flowing a little bit on this side, we're flowing, you know, around on this side and around in there. So I don't know, maybe 60% of the valve is flowing until you get up to there. I mean, you got to lift it like over 500 lift before you start utilizing your entire valve. Okay, so the concept of lift curtain is, at some point when this valve lifts up, there's enough airflow around it to where the size of the valve isn't in the way, right? And that's usually a fairly, I forgot what the number is. It's based on the size of the valve. So I think for this one I need to be, you know, around 400 lift, if I remember right. I'd have to go do the math. I'll put it up. I'll put the calculation up there. But anyways, you can see as this opens, you know, it's not this much up here, and we're still shrouded a little bit in that area. Like here's our 1/4 inch, so which would be 250, right? To get 250 clearance, that thing has to be opened up that far. Here's a 1/2 inch flow ball. Right? So, yeah, my cam's not going to be anywhere near that. So this area here, this little, I guess, maybe 20% of the valve never flows, essentially, is what this is. So that's why we're going to take and shave this down a little bit, radius this out. Now, up on the top side, this just needs a quick little chamfer. Let me get the valve out of here. So we see the seat of the valve right there. So it's not going to, that's just going to take a blend. Pretty much from there to there, actually, yeah, right about there. So about 25% of it, just a quick little blend. That's all that needs. We don't need to go way out on it. And then we'll have to do more here, because you see the wall, how thick that wall is right there. And you see how deep this wall is right here to get to the seat. That's quite a bit. Let's see, that's a 1/4 inch right there. So yeah, that's a pretty healthy amount. So anyways, that's what I'm going to be doing there, is radiusing that. Now I went ahead and did the exhaust valve the same way. It doesn't need hardly any. You can see our little penciled in line there over the red. It ain't going to take a whole lot in there. Now this wall, we're going to need to work quite a bit in here, but for the most part, then I'm just going to come in and just kind of roundy this right there is what I'm going to do. Because I got to take that whole little tip off right there. Now, I'm not trying to take out a bunch of metal, because I'm going to be a little bit challenged on compression ratio, because this, I believe, is around 9-to-1 with a factory setup. Okay, so I'm 30 over, so that gave me a little bit, and we shaved the heads down 6 thousandths. And the block's getting decked too, whatever that's going to be. You know, it's probably be the same thing. So it might be 10 thousandths there. So that bumped me up, but I'll remove this material, which is going to, you know, bump me back down to probably 9-to-1. So got to be careful at doing that. Just do what needs to be done. Okay, I'm trying to time this. I am 30 minutes into this. Now I did do video recording too, so I'm trying to keep that separate, because if you're doing this, you're not going to be doing video recording. Trying to get this where I have my light on there. It's not falling back too far, and it's not cooperating. All right, should be good enough for what we're doing. Okay, so I've done my rough cut around there. This is the valve I'm using. I've kind of dinged it because some of this area, like right here, right at the very, very edge, there's like a little lip there, and I'm having a hard time cleaning that out. I'll probably have to sander roll that. Unfortunately, it is super close to our seat that we see right there that I nicked. See? Yeah, I nicked it with a hard burr too, but it's right at the beginning, so I don't think that's actually in the cut. But I'll go in there and kind of polish that out when I'm done. But I was just trying to, I had the harder bit and I got in there and nicked it. It's like, got to be careful. It's so easy to do that. My other valve is this is a 178, this is a 188. And you can see how much I'm beating it up, but I can't get that last little lip down in there because of that. Okay, let's see how much 30 minutes of work done. So I've managed to nick my seat. Nick my valve. Let's see if I gained anything out of that. Okay, this is the 1/4 inch ball. So we're at 1/4 inch, so need a little bit still there. We're good and clear there. Don't need to take any more out. Looking pretty good. So right in that area. And then this whole area needs work here. That's a lot of material to take out, but we're getting there. Looks like this little area, I need a little more right in there for sure. But yeah, no way coming out. And that's just with a 1/4 inch gap, right? Or a 250 lift. So essentially it's like this area is like a not even 250 lift, even no matter how much you open it. But we're getting there. We're getting better. So that's 30 minutes of work. So that needs a lot right there. Just a quick massage. It's just a little bit right in there. Like I said, I might have to go to sander roll. Now let's look at the tools I'm using. Okay. Chief number 1 is a nice double cut bit right there. So that will jack some stuff up. And then I'm kind of doing my refining. I found this little angle one. It's like rounded right on the Dremel, and it's the same thing as a double cut. That's getting me pretty good. That cuts pretty fast, faster than what you think. And the Dremel, I like it because you can control it. And these are just little cheapy bits. What I might could do when I get up there closer, I may need to go to a little bit more roundy edge. Maybe I need a little point right there, but I'm having trouble getting that just a little bit of a lip and blending that in. So I've got to play with this stuff. Like I said, this is the first time I'm doing like chambers and doing valve shrouding, so a little bit of a learning curve for me there. I mean, I know how to use tools. I mean, I can jack this up just as good as anyone else, right? So anyways, I did have one boo-boo. I'm going to have to really watch that because that will probably polish out because I barely got it, but yeah, I've got to be careful. That's going to hurt performance there. But anyways, yeah, getting there. A lot of material needs to come out right here. A lot. And then it's got to be angled a little bit more as well. But it just takes time to do that. Okay, we're at 45 minutes. I am done with the rough grinding part. There's a little bit of smoothing I want to do, like there's a little bit of a sharp edge I want to take off. So what I'm going to pretty much use from here is just stones and try to smooth that out a little bit and get rid of some of those sharp edges in there. And then we still have around our spark plug area to do the softening in here and clean that up as well. Didn't nick the seat anymore. Well, I think I nicked the seat. It'll polish out. So that's what we got in 45 minutes. So not too bad right there. We got one valve unshrouded. This one's not going to be as bad over here. So I'll go ahead and get this one complete. That's the major one right here to get that done. The exhaust valve actually, yeah, unshrouding a help, but the thing is, your exhaust when it opens, it's going to be trying to draw from the intake and come over. So yeah, it's important, but not as important as this intake where that stuff's trying to come in, because it's the exhaust is just going to dump. It's, you know, that's the close spot to it, right? Hour and a half into it, I am done. I've polished everything out. I'm not doing anything else to it. So yes, I could do a lot of things to make it look pretty, but it's not going to gain us anything right there, right? So completely, not completely, but as de-shrouded as I'm going to get it. As you see right up here, we're getting real close to the gasket edge. I don't want to take it any further. Same over in here. I don't want to take it any further. Professional might know that you can get a little bit further in there. It's also just a little bit of softening I could have done right in there, but it's not a sharp edge. So we got this kind of radiused out and flattened out so that we get a little bit of our scavenging plateau in here. And what that means is basically as the piston's coming up and compressing the air and gas mixture, if you got a little bit of a radius in there, it makes it easier for it to shoot over to the spark plug and not get trapped in this area. Kind of the idea. Not a professional at doing that, but this is what I understand it is and what I can do with my ability. And this is the first one I'm doing, so the next one will be easier and look better. Like, I did this valve right here, de-shrouded it way quicker than I did this one. Now, that one needed a lot more taken out, but my hands and brain and all that's working better to do this because I got more experience at it. So it went super quick. Like 5 minutes here was like 20 minutes over here, right? So anyways, that's done. That's what it looks like. I've softened this edge up a little bit. I've kind of knocked down a little plateau in here. I've opened this up right here so we don't get stuff stuck in there. So there is kind of a nice little flat area between there and in here so that whenever both valves are open, the exhaust valve can help suck because it's going out, right? suck that intake charge in. It has a nice path to do that. So that's what I did right there. Tried to take the least amount of metal out as possible. So I think that's good. Like I said, you know, I could fart around probably another hour or two in it just to make it look pretty and not gain anything. So I think I'll just go ahead and clean this up real good, get all the nasty stuff that we got out underneath there. I didn't heat the seat anymore. Get that one out or not. But didn't jack up my valves, didn't do any seat in there. I got a little close right there, but the seat edge margin's right there. So got a little close there, and it's like, ooh, hey, dollar back a little bit. So what I found was on my rotary tool, the Dremel, this one right here works really good. It'll eat stuff out, and I can get up nice and close. I do have some of these other ones, like this one right here, that sharp tip. That helped out. I was using it, and I've used this for the spark plug hole, the roundy end one right there, to get down in there as well. But these have that little ridge right there. Pop another valve out there if we can see over here. It's like it's machined down slightly, so there's like a little lip in there that I had trouble getting out over on this side, but I think I figured out how to get to it, which tool to use and how to use it over here. I didn't have any issues, but over here, that's why I nicked that seat, just barely going into it. I don't think I got into the margin, but that's why I did that. So that's the tools I'm using. I'm also using the little stone right here, and I just got one of them like cheap Amazon kits, you know. That's all I'm using here. I'm just going to use them up anyway. I didn't use this a whole lot. I used it a lot over in this side because it was rougher, but I did a much better job here, so I didn't even use the stone over there. I just went straight to my sander roll right here and like my flapper disc right here. That's all I used on here to clean that up. That's part of the process of learning, is as I do a better job, I don't have to do the stones in more intermediate steps. I save myself time. Take two with the spark plug in. Okay, so what I found was actually the same thing, almost identical as not having a spark plug in, as far as what is happening. Okay, one thing to address. The way I'm picking up flow, I have the pitot tube sticking up in this big hole, right? So it has to have air coming in. It's a very turbulent air, so it could be hitting all around and then getting there, and I don't know where in that 4-inch tube the air is going. So if I'm not picking up, if it's not hitting that velocity probe and putting that back pressure on to counteract our vacuum pressure, I'm going to get a lower reading, right? Because they would read you know, basically 0 because they have the same vacuum pulling on it. So that's how this is being measured. So that's why I think at 100 thousandths lift, I got a little bit less water column over here, which would indicate less flow. But at 200 thousandths lift, at like a 0.475 inches of water column, and I went to 1.25. That is the biggest gain on here, and that's almost triple, well over double. Does it double the flow? I don't think that's what's going on, double the flow, but that is this very strong indicator that I made a good improvement there. 300 the same way, almost double. It went from 0.6 to 1.05, so pretty close to double on it. And then at 400 and 500, it's pretty much the same. 500 shows it lost a little bit, but what could be happening is as the valve opens, it wasn't really getting good airflow coming around. Now that airflow is coming in and mixing with this airflow on the other side of the valve. It was unshrouded, and now it's actually slowing down some of my flow at 500. But could be what's happening. Not for sure why my higher lift lost in there. But it's pretty close. You know, 400 is the same. So at 400 it's the same because, you know, the valve is shrouded coming up, and once it gets past that, then the shrouding doesn't matter anymore. It's flying around, right? So once it gets past that, it doesn't matter So it could be there, not there, you know, whatever. So that's what we got going on with that. The increase in my low lift flow is exactly what I want with the smaller cam with the lower compression ratio. I'll probably still be around maybe 9-to-1, small cubic inch engine, not spinning a lot of RPMs. Low lift flow is where I'm just going to jam pack the cylinder. As soon as that valve opens, it's just dumping the air fuel mixture down into the cylinder and filling it up. That's the name of the game there. So that's the gain I want to see right there. I could care less at 500. I mean, the cam I'm putting in is like a 513 lift. So yeah, I'm barely kissing that. Okay, well, I think that's it for this. The next time we're going to go over the bowl porting, and then maybe those numbers will change right there whenever I go in and bowl port that. And we still haven't done actual porting yet. So I guess we're actually getting a bowl port, because bowl porting, you know, that's in the port. I haven't even touched the port yet, so I haven't ported it. Semantics, I know. Okay, bowl porting. So the bowl area is right. I'm considering it the valve guide area here, all the way up to the seat. That's what I'm going to say I'm doing bowl area. What? Poor starving kitty. You just ate, dude. I'm over here. Come on. You want to jump up on the table? I got the camera on. So anyways, the first thing I'm going to do is dress this area. We see our machined area right here. And it ends, and there's a little bit of a lip right there. So I'm going to use this tool right here and just come in and get rid of that lip. So I may have to flip the head around, that way I can get the short side. So this is the short side radius is right in there, right? And that's the long side or whatever. So that's the first thing. Then I'm going to address probably bowl ratio. We're at 86.4 right now, and that's just right across there. Need to make that an 88, so there's a little bit of meat to cut out. This actually comes out and tapers in all the way around. It's wider at the bottom, basically, right? So I'm going to come in right at that machine mark right there and work that area, mainly from here to there is what I'm going to work until I get that bowl ratio right. The short side, like I said, I'll flip the head around and do the short side later, which I'm not going to do much. Probably just kind of polish it out just a little bit. I may come back and do a little bit of roughness on there because I want it to stick to that short side better, but I'm not taking it down. I'm not widening it, not doing anything to it at all. I want to leave it, basically get rid of that lip and leave it alone, and then work on bowl ratio from this area around. The last thing actually next to last, the other thing I'm going to be doing is, here's the spark plug. So this air is coming in, and it kind of almost wants to come around there, but it hits that wall right there. I'm going to just whack that wall down right there and kind of point it right towards the spark plug. And then over here, that's kind of doing what it needs to do, but it comes up and hits that edge there. I'm just going to radius this out nicely and probably just leave that alone. I'm not going to go too crazy on that area. I usually don't. That's kind of beyond my skill level right now to do it correctly. I mean, I can totally do it incorrectly. The other thing I'm going to do is my 3D printed flow balls. Is if we notice this edge down in here, a quarter fits pretty good in there. It does not fit in there. So I'm going to widen that area at the boss area. I'm going to widen that out. The valve guide boss. I got a cat over here just meowing like it's hungry or something. What do you want, dude? Oh, you just want some pettings. I'm giving the camera and the cylinder head too much attention is what it is. And then over here, I'm going to go my next size up that I have, which is a 5/16. That's roughly that size there. I'm going to make sure it's open to 5/16, open that to 5/16, and then lastly a 3/8. I'm going to come in there and make sure a 3/8 fits in there, and I'm done. I'll probably smooth the bowl out, just the bowl area, I'll smooth it. And of course, these little yucky growies down in here, I'm going to get rid of that right there, that casting gunk. And that's going to be our bowl port right there. Okay, we're smooth. A little too much light, not enough light. Too much light. It's cameras. They're never happy no matter what you do. But yeah, that's it. Just dressed it, and then I come back with a sander roll on the Dremel and touch that up just to smooth that area out a little bit, and that's it. We're dressed. So I think I'm going to tackle these little ugly spots right there, get those out on the edge, and then start working this boss area a little bit, and then well, like I said, do the other part. Okay, I got the big bit right here. I couldn't do a whole lot with it just because we're getting tight down in there on the safety glasses falling on the floor. Whenever I get to the port, I'll be using that bit more. So I went to this, which is roughly a 5/16 ball, right? And I did this. I went down, you're kind of in the way. I went down in that area, and I did the other side. I need to do a little bit more work in there, but I just did that number there, and then I did my roundy round radius. And you can see our angle, I'll get you a little closer, we can see our angle is starting to take shape there, and kind of smooth that out. Got more work to do. Let's look at our flow ball. This is our 5/16. Looking pretty good, need some right up at the end, and right there the beginning looks good, but we need to take a little bit more of that boss down right in there and finish that out. So about 2 minutes of work or something like that's all we need there on that. And then I'll change my bit type and do that area there. I think I'm gonna run one of these little tapered one, the flame looking one, I believe that's what that's called. I'll probably run that one down in there. And if I get to where I need a little bit more length, I actually have some longer versions of those that I can chuck up if I need to get back a little further, if I just can't get down in there good enough. And if wielding the Dremel is a little too hard, you see I got braces on, right? Because this stuff kills my wrist. I'll wake up and it'll be like my whole arms are on fire. And then won't be able to use my hands for a few days. But I do have the Dremel little attachment somewhere. I don't see it just yet that I can put on there, like a little hand attachment. So I can put that in there, and that'll make a smaller area to get down in there if I have to. But so far, I don't think I'm going to have to do that. So I am 30 minutes into doing this right now. I forgot to actually time the beginning, but I'm going to say a good 30 minutes into doing what we did right there. Probably not quite that, but we'll just call it 30 minutes right there, which brings us to 2 hours total into this head port, which times 8 is, you know, it adds up, right? So that's, 16 hours to do a whole set of heads. Which, I mean, as we see, our gains are coming pretty quick. And that's usually how it is on something, is you get low-hanging fruit, things that occur very quick. You get big gains for not a lot of effort until a certain point, and then you get diminishing returns on there. You have to put more and more and more time into it to keep getting gains. But what we're doing here is, this is the easy stuff right here. All right, now that is rough. So I'll have to come back and clean it, but I'm going to finish my cuts in there and probably just show you what it looks like complete now that you get that idea. And our bowl is about done. I need to measure this to see how much that dress added, and then I'll just, you know, kind of hit these little corners in here or whatever I need to do to finish up that, to get it to 88%. All right, all done with this other than short side. I'll have to flip the head around to do that. Just under an hour into this. So Look right in there. We're polished out and smooth. In here, opened up the throat ratio. You can see kind of what I did there. Right up to that machining mark is where I'm measuring. Same over here, right up to the machining mark. I just come in and just had to get pretty aggressive on that to get it to come down. I kept doing it and everything wasn't moving because I was just, trying to use a stone or whatever. Be careful. I haven't done throat ratio actually measuring it. I just kind of go in there and, do it a little bit. The rest of this, I've done this before, so it went super quick in here. That's a lot to do. And this is the way all these are going to go. Like I'm timing this one, but this is my first one. The next one will be quicker, and the next one will be quicker, and so on, and so on. What you can see right here, I've angled this and kind of brought it back to here, angled that whole edge coming up to the spark plug. I just smoothed that one out. Everything's been hit with the sander roll as best as I can get to it in there. So that's all I'm going to do for tonight. The next thing you're going to see is this flipped around, and I'm going to go over the short side. See, we got a little bit right there, like this kind of necks over, lips over. I want to take care of those little edges in there. I like kind of radiusing that out. And I still got a little bit of lip in there to do that dressing, but I'll be able to see that when we get to that spot. But this is good, and yes, you're going to see tool marks and everything, but that's not an affecting flow in there. I mean, maybe a hair if you're like super. There's a 3/8. I kind of like that. I could take out just a little more back up in there, but we're pretty much 3/8 on that one. And our 5/16 goes in up to there. I could do just a little more right back there, but I think we're pretty good. Before we couldn't even get a quarter in there, and we got a quarter going all the way up. Right, and the same thing with the 5/16 on this side. We get that all the way in there. So that's how much metal I took out right there to try to get those where they are. And it's hard to tell. You got to have something to gauge it by. All right, well, I'm going to take a break. You can do whatever you want to do. Go get your tasty beverage. And then when we come back, we're going to be doing the short side radius. All right, we got this flipped around here. So I just need to do my short side right here. And I was trying to get that to dress out right there. So I'm just going to come in and get that little ridge out right there. And it kind of comes in and has some weird, like right at the throat, has like a little weird area. So I'll probably radius that out as well. Then I'm going to jump over here to the exhaust, come in here and do a good cleanup up in here. And it's got those ridges in there too, where the machining ended basically and the casting began. And it comes all the way around. I'm just going to take that out, touch it up just about the time I take that ridge out, because it's right at the throat. That's going to give me my throat ratio right there. And 6 minutes and we're done. I mean, that easy. And, I've done this type of stuff before. That's generally what I did. But, I just went in there. I mean, that took like 30 seconds to knock that down and we're done. Went over here with the sander roll right quick, vacuumed it out, and took a little bit to get this upper ridge in there out. Can't see it, can you? Because it's not there. And just that little ridge around there. Took a little bit to get that out. I just grinder stoned it. I didn't get out a cutter tool for that. It's no need in there. And that is it. We are done with the bowl port. My bowl ratios are now correct. So I'm 86% and 88% on these two right there. And that's what the master Charlie says do. So on these heads anyway, so that's what I've done, and that's it. So I'm going to just kind of run my hand around everything, look for any sharp edges I might have missed, don't fill any. All right, just check that out. Let's see what we got. We have at 100, let's see, cut one seemed to drop down, but it's pretty turbulent. It's still kind of turbulent in there, but it did pick back up. And 200 lift. Saw a slight gain in there. 300 lift, slight gain. 400 lift, slight gain. 500, the same, which 500 was down on first cut. So it's still down a little bit. So how would I get 500 lift back up there? take the short side radius and start messing with it. But then all the other flows I have going up to 500 is going to go down. I'm going to lose 1, 2, and 300 left. So for this, I'm not going to worry about it. All right, intake manifold, 1973 40 stock condition. Got the gasket up here, so let's look at this. Matching pretty good. We got that little area there, which would correspond on the head to right here. Actually, it'd be the pinch area is where that's coming out to. Right there. So we definitely wouldn't want to do anything there because it's just going to run into the pinch, right? Because we're mirrored. Overall looking pretty good. That would be lowering the port. I don't see anything really to gain from it. Our flow issue is the head, not the intake. Let me show you. This is set to the width of the port on the cylinder head. Just mowed my yard, so now I'm all sniffling. So right in there. That's what we got. Widest part. Come in here. Yeah, the intake is not the problem. Let's try height. Same thing. Yeah, that's not the problem. Intake, not the problem at all. Need to work the head. So what I'm going to show you how to do is how to port match, because I'm not going to gasket match the head. That's not going to do us any good whatsoever. Now, if I had aftermarket heads, that would be different. But if I had aftermarket heads, I'd also have an aftermarket intake. So, yeah. Now, 360 heads would be something a little different too, but with the 318 heads, those small little bitty ports, there's no reason to gasket match this at all. We're going to have good flow. The 340 ran what? It was rated at like 275 or something, and we know it was underrated for various reasons, right? This is going to flow what we need to flow. I am going to do some stuff to it. I will come in and clean any of the lumps and bumps out of here. Not really much to clean on it. Pretty clean in there. Nice straight shot. But anyways, I'll probably come in and put some sort of a texture on it, just a rough, probably use this sander roll here. I don't know what grit it is, but it feels pretty rough. So it's probably like a 60 grit or something. I'll just come in there and do that finish on it. And we got sharp edges on the upper H. So I'll do some upper H, like that lower hole area. And I don't think I can reach down in there to the lower H, but I'll see what I can do getting down in there and dress those. So, yeah, we're just going to do a port match. So port match, how I define that is I'm going to make a copy of how these ports look. Essentially, I'm just going to put, I like to use a piece of like heavy graphing paper, like the big 11 by 17. I'll go and cut me a strip on there, and I'll do the same thing. I'll kind of clamp it, tape it, whatever, do my bolt holes, ping it, just like making a gasket, and ping it all the way around, and it'll be an exact match of this, and I'll write on there, head side, intake side, forward, back, and then, since this side of the intake is the passenger side, when I get done with this head, this is going to be the passenger side head. So I'll need to mark this. That way everything goes together and lines up right. Okay, here we are. Just kind of the basic setup. Ball peen hammer, just like doing a thin gasket. Now you don't have to go all Viking on it, try to send a hammer through the intake manifold. You just got to tap the thing on there. So bolt holes are always a good one to go for because that's your alignment right there. These kind of taper in a little bit, some of these, so makes it a little harder to do it. But we can just go around there. That's kind of how our bolt hole looks. And you don't have to get it all the way, as long as you got a mark. Then you know where your bolt hole is. That one's a little ugly on the bolt hole because it's so, you know, the way the casting is. But, you know, we've got it kind of held in place. Sometimes I'll come in here and take that out and put a bolt in it. You can come back with a razor or whatever. Generally know about where we're at. That's the idea. But you can see that one ain't really, you know, that's kind of how it is. On certain manifolds, they cast them like that. Your 302 manifold, like your fuel injected and all that's all nice and aluminum. So we're just going to come up and do this port. Alright, so I put that on there. This is not the same size. I was using that for my alignment, and actually they're, yeah. Anyways, and we saw the casting little difference in there, so whatever. We're close enough for what we're doing here. Yes, that port is lower on the intake manifold, and that one is higher, so if we was going for all-out 100% performance, we wouldn't be using stock parts, so it doesn't matter. Alright, so this is the port we're going to work on. This is the one that I want to get complete and then send it out for flow testing, and then the one adjacent to it, the opposite side, will be the other one for flow testing right there for base ported. That's the idea anyways. So as we can see over in here, this one's actually lined up fairly good. This is just going to get a little bit of a radius on here. Now remember, when we come in here, this is lipped over a little bit, so that'll be part of that radius, is to get rid of part of that lip. Not going to do anything on the bottom other than just a little radius there. I don't want any sharp edges. Now according to Charlie, whenever he did the 302 casting, right up there, this pinch area here needs to be polished. The rest of it can have a rough texture. So I'm going to go in and get rid of, if you can hear that, all the casting crud in there is what I'm going to do. And then I'm going to come in here and work on the upper. You can see where we got some room to work there. And filling up in there, it kind of curves up just a little bit, but then it gets tighter. So I'm going to work that area in there. We also have where this hole is here. They gave a really big boss for that. So I'm just going to straighten this wall out right there as far as all the goofy stuff like that, and raise it up just a little bit in there and punch it straight through, right? And then I'll come in and do a rough texture other than the pinch, and that's it. I can do some work here, but I'm going to need to get this off the bench to really work on it and get the valves out for that. So that's what I'm going to be doing right over there. Okay, 15 minutes in, and you can see we're going to start. You see how much I have to cut out to get to the red there. So I am not going to try to take that all the way down. That's going to be, I'll take that right there and taper it in to probably about the pinch area. I got this smoothed out in here. I've hit pretty much all the edges. I'm ready to start with a stone now on there, and of course polishing that out. I've done my little area up in here. There's a little bit of a groove in there. I guess that's where they put the mold together or something. Two parts of the mold, it oozed out, but I smoothed it decently. I could go over it with a smaller bit with a Dremel better. Now all the way down in there, I have not got in here. I'll have to go with a longer bit. That's as far as I can get with the big bit on the drill, on the drill bit, on the drill. So I'll have to go to my longer ones over here. I can get it out of the package. Come on. So I got these right here, 1/8 inch, so they'll go Dremel or drill. Just depends on which one works better. The Dremel doesn't really like those. You can get a bit floppy and all that stuff going on when you get down to the end. But yeah, that's where we're at. 15 minutes of work, roughed in. So now it's just to go in and, like I said, I'll taper that all the way down, and then we'll just start polishing everything out. All right, 45 minutes in, I consider this done. This wall's nice and smooth. This is all radiused out in there. This is rough, but it's not as rough as what I want it to be. But it'll do. It ain't just completely sand or rolled smooth. I was able to get all the way back down in there and kind of touched it. There's still some casting stuff in there, so it gets rougher as we get down in there just because I couldn't reach it right all the way back in there. So pretty much everything has been touched. We've addressed the areas we need to address, and we're going to leave it alone. This is a stock 318 head after all. So what are we at? To finish one complete port and chamber, I forgot. I'll have to look at my notes. I think it was at 2 hours and 15 minutes, so plus 45. Of course, you know, it was like 10 minutes to do the little gasket thing. That's kind of fun. That's not porting, but whatever. So about 3 hours is what it takes to do one cylinder. So 3 hours times 8 is what, 24 hours roughly? Not bad. I think we're going to get some really good gains off this right here. So I do need to throw it back on the flow bench. Are there things I can finish doing? Yeah, I could take this out further. I could polish more. I could go in the chamber and polish it. But for the time that I'm putting into doing those things, the gains just aren't there. I mean, yeah, there's a little bit here, a little bit there, you know, a couple sieve film here or there, but we got the big majority of it. 80% of what I'm going to get out of this head is done. Okay. CC the stock and the modified chamber. Looks like I added about 2 cc's to this right here. So when I CC it, what I got is just my block, you know, taped it off here. But I scooched that over because the water will actually bubble up on you and make you be quite a bit off. I figured that out. And then I just use, you know, one of these right here. Got our numbers in there. This does 30 at a time. Great. And make sure to get the air bubbles out, and I just slowly fill it up. And now you can use plexiglass, which would probably be easier, but I don't have plexiglass. I have one of these from when I did the flow bench. But anyways, I filled it up, and that keeps it nice and flat, so you're not adding extra and getting a wrong number. But come up 58 and 60 on there, which is pretty much where the stock ones are. That's within that range too, so that's another good guess there. So I need to get the block back and check my piston compression distance. Once I know how far down in the hole the piston's sitting, I'll be able to calculate my compression. From there, and once I get the flow numbers on this head, I'll be able to get numbers for a camshaft and figure out what kind of cam I can run, right? All right, what'd you think about all that? And as promised, here's the pictures of all the liquid testing right there. I'll leave those up for you to gander at right there. I think it come out pretty good on my bore adapter. I got about 180 degrees of fluid on that thing, so that's a pretty good setup right there is what I think. I think I pretty much have gotten 80% out of this head of what it's capable of doing. The next 20% would take another 30 hours. So again, to recap, about 3 hours into doing one port on here, or one cylinder on here, and that's it. On the exhaust, I really didn't touch the exhaust. Not too worried about it according to the testing that Charlie did. And the other thing is I don't have my headers, so I can't do any kind of port match, so I'm not going to do anything on the outside. So we just did that, you know, untrowel the valve and bowl cut, and that's all I did to that. I didn't do anything on the port side for this video right here. What we're going to cover here is the flow test data that I got from sending the cylinder head off to have it checked and finishing up the port. So whenever I sent the cylinder head off, I didn't know what header I was going to use, so I couldn't finish the exhaust port. So we're going to be going over finished the exhaust port and a little bit more ideas, kind of a overview of how I went through and did the actual port part of that, like the gasket match. I actually used a port match on this right here. So let's jump into the flow data. All right, doing a little in-office video here. I had to switch to my phone because the GoPro, it just picks up all kinds of echoes in here, and it's just terrible. So we're going to go over the flow data that I have right here. So I actually plugged it into the computer, so I'm going to read it off the computer screen, and then I can do wherever I decide to do the little pop-ups for the flow. So a couple things. This flow testing was at 7 inches of water, not at 28, which is the standard one, right? So I had to do a little bit of conversion factor for that, but I'm going to go through it and we'll see when we go over the numbers right here. The other thing is the exhaust port was not finished because I didn't know what header I wanted to use, so I didn't finish the outside port. So that's the next segment coming up, is actually testing out or finishing out those exhaust ports. So what do we get? So looking at Stanwise cylinder head flow data is going to be my conversion factor, right? So looking at, see, I did one port, one cylinder unmodified, and then the other cylinder was my modified side by side, the two center ones. And I think a lot of the flow test data that's out there is they do all the ports and take average on those. So that's not exactly what we did there, but I'm paying someone to do this, not doing flow testing myself. So what I come up with, the exhaust flow port was, I could read it off this. So we had, let me just start with the intake. So the untouched at 100 lift was 62 CFM at 7 inches of vacuum, right? And I went down minus 854 at 100, which that's pretty much what happens whenever you start porting. You're going to lose your low end a little bit. So I come up to, at 202, it was 100. Ported was 116, so plus 16 CFM gain. That's pretty good, especially low end and at 200. Usually 200, you kind of tend to lose that. So I also had 136 at 303. 158 is what it came out to, modified, plus 22. Got 168 on 404. What's this, 404? 400 lift, 168, so that's plus 20. And at 500 lift, I got 164, which is plus 14 CFM right there. So we know that those plus 16, 22, 20, and 14 at 28, it's going to be higher than that, a bigger gain than that right there. So what I did was I looked up the 302 head on Stanwise cylinder head porting, and since I have the stock numbers right here compared to stock numbers, each lift, I looked at those and compared stock to stock and come up with a conversion factor. Now, this is not the absolute number, because to get that, I'd have to flow it on the same flow bench on the same day with the same everything and flow it at 7, flow it at 28, and then come up with an equation that converts them and all that. That's the only way to get this data accurate from one flow bench to another, one tested at 7, one tested at 28. I know there's a chart out there, but that is not correct, and I'll tell you why. Because at 500 lift, this thing flowed 150 at 7. If you go by that chart that they come up with, it says times 2 to get 28. This thing is not flowing 300 CFM in stock form. There's nothing to do to this head to make it flow 300 CFM at 28 at 500 lift, or any lift that you open it up an inch, it ain't going to flow that, right? So I kind of had to throw that out, and that's why I did the conversion factor. So I'm going to go over those numbers. So what I come up with, each lift I did its own conversion right there, and I'll throw this up there as well. And I'm looking over here, and I know you're there. And I compared it also to Charlie's. I'll link his channel down below. He did the Quickie port for the Mission Impossible build. This is a similar thing here. So I watched them, and I try to replicate his Quickie ports, what I did. So he flowed at 28, so that's why I had to convert it. So on my intake, I was 120 at 200 lift with a conversion to 28. The Quickie port was 126. 300, 176. Quickie port was 180. So within a few CFM. And this is where he picked up at 400. I was 202, he was 218. And then at 500, I was 210, he was 223. So still pretty close right there. You know, he's a professional going through and doing it. I'm not. And we don't know exactly where these numbers are because this head wasn't tested at 28, but this is a good generalization of where it should be, and the numbers make sense because if I'm flowing 210 at 500 and it was 190 in stock form, and I know that I gained, what was it, 16 at 500 at a lower flow rating, well, 16 100, that's 206 right there, right? Even if we just, you know, I know I gained 16 CFM and the stock flowed 190 at 128, 16 206, I'm claiming 210. I think that's a very plausible number right there. Anyways, I'm sure someone will probably disagree with that, but I really don't care. So anyways, that's what we got. I'll throw that up there. Pretty close. The exhaust didn't fare so well because it just wasn't finished. The exhaust I had gains. I had -6 and -4 at 100, 200. 300 was plus 8 CFM, 400 was 12, and this is at the 7, the actual measured data right here, not anything converted. 400 was plus 12, 500 was plus 12. He floated to 550. It was still picking up. It hit 114 versus 112, 500 to 550. So it did pick up there, and this is unfinished, still plus 12. So I had pluses. I think that would have went up significantly. It's not where I want to be according to this flow number. The ratio, the intake to exhaust ratio just isn't there. It's like 60 something percent instead of being like the 80% right there, flow of the exhaust to the intake right there. So not where I want to be. Let's see here. Converted. We'll just do the couple high ones. 400, I had 130. The Quickie was 158, but then again, the Quickie was finished. And 144 at 500 left, and the Quickie was 165. There again, not finished. So there's more to be done on that exhaust port, and we're going to get into what I'm doing on there to finish that out. And well, I can't afford to pay for more flow testing to be done on it, but we know we're directionally correct and kind of where we stand with the stock port with the home porter doing it. Okay, I'm doing some final stuff on the head porting. This is the exhaust side. I know what exhaust system I'm running. So what I did, I just took and put paint on the header, and this isn't all the way to do it. There's a bunch of ways to do it, but I put some white paint on the header because I knew it'd show up, and put it on there. You notice the header isn't perfectly flat, but we get a general idea where we're at. So the top really don't need much, maybe just a slight radius on it. This inside, pretty much all of them were the same, just a clean up, but don't take any off because it's going to be going into the header. The bottom I'm going to leave alone. We'll get to that in a minute. Then the side, I can't take that much metal out because, see this stud, there's a water jacket there, right? So we come over here. That's not a water jacket, but I don't know how thick it is. I'm not going to pour it out a 1/4 inch, right? But I'm put a healthy radius in there and take some of that wall out because I can feel it is tapered in like that. And what I can do is straighten it out and then do a radius, right? The corner here, that's the bottom, but the corner there, I can smooth that a little bit, but really there isn't anything going on here, but the only reason I'd smooth that is down in there, it kind of divots in, and then it pulls back out and gets thicker right there. So I want to smooth that transition out so there's not a dead spot right there. But there's really not too much going on the bottom. Now the bottom is where, if you're going to have reversion, that's where it's going to be. So I'm not going to do anything with the bottom there, maybe just a slight radius in there, because whenever reversion, which is exhaust gases coming back inwards in a low pressure area, when you're in overlap period, that's what gives you that cam chop, is reversion, right? Because you're bringing exhaust gases into your intake charge. So that'll help prevent that from happening right there. right? So it's pretty healthy reversion ridge on it with the headers that I have right there, which are just, I don't even know what brand they are. I think they're Hedman headers. There's a tag on them somewhere. The Hedman car headers. Yeah, that does you a whole lot of good. You can't see what the ports are. So they're, I wasn't really prepared to show you that half, I guess. So that would be a two-hand job to get this out, I think. But we can do that trick right there. So that's what they look like. Get it put back up in there. So anyways, yeah, pretty happy with that. Just going to move forward with knocking that out. That shouldn't take a whole lot of time. And then I'll just kind of clean this out and smooth it because this is the exhaust port. And it doesn't have those stupid nubs sticking up in there like a lot of the heads do. Where the, see where that little hole is right there? That's where the EGR comes out. Or the air injection comes out right there. Trying to think, is that the air injection? Brain farting on what that is. It's getting plugged, that's what it is. But a lot of them have like a nub that sticks up, like the Ford heads have that nub that sticks way up in there, a giant hump in there, and just completely gets rid of your flow in that area. Like, you can't even get your thumb in there hardly. So these actually are pretty smooth on these castings. I think the earlier castings, they had a little bit bigger bump. I know the 360 heads, that's the ones that I've done more porting on. They definitely had a big bump in those. So anyways, that's what we got going on here. Just a good cleanup is all I'm going to do with this. Everything else on it's done other than the intake side. I need to get my intake manifold back from the machine shop. It's been clean, so this week I want to get that done. Then I can have this head completely done, clean it. There's my intake valves. Here's the exhaust valves I'm running versus, put the other one somewhere. The other one is actually a nail head. It doesn't have that cone shape in there, but it's got the goofy height for the dumb rotator cup things, which means the spring is like that tall instead of that tall. So I just want to buy one set of springs. I don't want to buy two sets of springs, you know, because that one oddball one. So that's why I'm going with those. But those are just a Melling or whatever stock replacement ones. Okay, now there's a little bit of review here. I just took my piece of paper here and put it on the intake manifold, right? Because I'm port matching the manifold to the head because the manifold is the 344 barrel manifold and it's a lot bigger port than this, right? So I got videos on that showing how much bigger it is and all that stuff. This is just, like I said, a review of what I'm doing. So this is a port match. So I take my piece of paper, you know, of course, label it, flip it around, put it on there. So this is an exact match of what the intake manifold is on the head, and you see the work we got to do. So I dusted it with paint, and I think it's time to pull it off because I used just a quick drying spray paint. You don't want something that takes like a couple hours to cure up, right? At least dry to touch, because that'd take longer to do this. And now we know roughly where we need the port. Now we're not going to make it exactly that big, but we can come down in there and put a nice fat radius in there. You see the edges just like the other head. Let's just do a radius there on the push rod holes. That's all I really need to do. Looks like that one might be shifted a little bit more, but this is taking account whatever shifts in the intake manifold in the head. The other thing you can do is gasket match. In this situation, I think port match is better because this is the 2-barrel 318 head. Let's see. We'll just lay a gasket over there. I wasn't ready for that. Got to move the fan, walk around the vacuum, you know, all that good stuff. Get a head gasket out of the way. All right, so if I was going to gasket match, that is just not what you would do on a set of heads. That's just massively, I mean, you just couldn't do that, right? I mean, some of them aren't all that bad, but you see this one here, that's way off from what the intake would be. And if I had a set of nice aluminum heads and a nice aluminum intake manifold, then that would be different. That would make more sense. But it's just what we have is kind of a mismatch, and this is making everything work together. And this is kind of what you're going to find with production anyway. That gasket's way bigger than your production head, even the 360. So now on the, like again, on the aftermarket stuff, like these heads here, if we put that same gasket on there, that would be different. Let's do that right quick. So we saw how much bigger the 4-barrel gasket is. That's why they make a 2-barrel gasket, by the way. And if we go in and probably put the thing on upside down or something, it'll look goofy. So now that would make sense to get it lined up good and do a gasket match on these heads and an intake that matched it, right? You see, there's very little to do. We ain't just trying to hog out a 1/4 inch over here. And then you could, of course you want to taper it as the port goes down. You want to get narrower and narrower, right? That way you're increasing that velocity and everything. You don't want to increase your velocity and then open up and you lose that energy because the air is going to expand for the big opening, right? But the only time you want to do that is when it's going into the cylinder bore. So anyways, again, a review, and I just used the ball peen hammer, had it up there, and just act like I was making a gasket. And that's a technique that I use for a situation like this where I want to port match, not gasket match. Got it finished. Not a whole lot to do on those, but there is a little bit to do on them. This is what we look like. All done up right there on the engine. You can kind of see the pattern I'm running. We got our intake over here that's at gray. Playing around with spacers. I think I need to make a custom spacer for this because a 600 Edelbrock will fit these perfect, so it wouldn't need a spacer with a taper. It just needs to be straight down. But this is a little bit one size bigger, so it could take a spacer. This is the size of the 600 Edelbrock secondary, and then taper it down into there. That's a whole nother thing. So got an idea for that design. But yeah, there it is. It's on there. We're good. It's not bolted on with a gasket, but I'd put it up there just for mock-up. And I think I'm going to go ahead and run these fabricated aluminum valve covers on there. If not, I'll have to paint a set of valve covers, and it's like, well, do I paint them black or do I paint them gray? And yeah, whatever. That just solves that whole problem, right? And with these, there's a problem with the brake booster, fitting those up with the larger, more common brake booster. Well, this doesn't have power brakes. Problem solved. They're meant to go on this. All right. Well, we're looking pretty good there. Just want to do a final. Oh yeah, and I plugged my little Huya holes in there, and that one's in. It's a little deeper, but I got those plugged up as well. That way I'm not shooting exhaust gas or whatever out on those. But yeah, I think that'll sum up what we're doing with the cylinder head on the engine right there, and just kind of finalizing the ports and everything on there. Just kind of wanted to go through that and flow data and all that good stuff, right? So I hope you enjoyed that.